The idea of the day is for you and everybody else who attended the conference to have access to ask questions and work on project with LabKey staff. So we have all of our developers and testers available here for you today to just sit down, ask questions, come up with project, anything that you want to ask or have problem with, it's your time to ask questions. If you have problems with a laptop, if you don't have a laptop, if your laptop is not running a LabKey or you need access to a LabKey server, just let us know and we can help you out with that. We have an online training server if anybody just needs access to that. And any one of our developers can help you set up your machine as needed. Some housekeeping. So restrooms are right outside the door. We'll have lunch served at the kitchen area, same as yesterday for whoever was here. And you'll have beverages and snacks available throughout the day. So I think we'll get started. Our first presentation is from LabKey. We'll have Carl Blum and Corey Nathie talk to you about the visualizations with LabKey Server.
All right. Thank you, Avital. This is about sort of visualization support in LabKey. Corey is one of our software developers, been working here for a long time at LabKey, has done a lot of work on visualization. And we're going to structure the talk mostly around case studies for different types of visualizations that we've done recently that sort of give you a sense of types of things that we've been working on and what's possible in LabKey. So just a little bit of background. So importance of visualization, as we saw a lot during yesterday's talks. A lot of themes where there's an explosion of data, lots of data out there. It's very difficult to see any sort of patterns or see results or find anything looking at the raw data or looking at grids of data. Visualizations can help you see new relationships and patterns that may not be apparent in the raw data. This visualization is kind of interesting. I don't know if you can't see it very well, the blue one. It looks like a map. It's actually, this is the Facebook Friends visualization that Facebook intern did in 2010. It's actually plotted relationships between like the top 10 million samples of data and the friendships, and so it's interesting to see sort of how it actually renders into sort of a geomap of relationships. And lastly, visualization can enhance discoverability through interaction. So we saw a lot of this in some of the talks yesterday's with Oncoscape in particular, where you have a visualization, but it's very interactive, and you can discover and look for new patterns. So visualization support in LabKey Server. So we have kind of the standard. This is not an exhaustive list. What we call built-in reports. So these are reports that are built into the server. They're built into our grids, built into our data views, managed views. These are kind of the popular ones. Of course, our reports. Very popular. A lot of people are able to build very powerful visualizations. And then some of these newer type of plots. So box, scatter plots, time charts available in the study module. These are more of our client-side rendered visualizations, where they're rendered using the visualization API over D3. Secondly, we have API access. So these are basically JavaScript APIs. This is our client public API. So the visualization API, which we'll talk more about in some of the case studies, renders over D3, and then a newer class called LabKey Report, which allows you to programmatically manipulate sort of artifacts from that come back from an R report. And I'll show an example of this a little bit later. There's also some methods in this class that allow you to control session, largely designed to work with RServe. And then the third category is what we call kind of external tools. And so these are things that LabKey servers integrated with. They're separate tools. They're separate applications. So a good example is R and knitr. And then something I call command line. So the framework in LabKey for adding different types of scripting engines, you can add if there is an application that can be invoked externally via the command line, and it can sort of take data in and produce data out. So an example is maybe it's out a plot. There are ways that you can integrate that into LabKey, so you can render those charts and feed it data through LabKey and have it render in the server. So with that, I will talk about our first case called survival curves. And you may have saw this a couple times yesterday during the talks, so I won't spend a lot of time on this. Meyer estimates, generally used to predict the probability of survival over time. It can be used in the medical field, it can be used in manufacturing, engineering. It has an advantage because it can account for censored data. So, for example, if somebody leaves the study before there is a final outcome. So we actually built this visualization as part of Argos. You might have seen this in Paul Fern's talks and some of the other slide decks. But the overall design is that we want to display a survival curve, for all patients, but we also want it to be interactive. So we have, not showing it right now, but we have different filter histological categories. And so the idea is that as you check or uncheck, the plot will re-render. And additionally, in Argos, if you attended that demo, there's patient filtering. So the data sort of respects the filters and selections. And so as application level selections and filters change, we want to sort of see that in the plot and have it re-render. So that's the basic scenario. So the design implementation we decided to use R on the back end to generate the survival curve data. And then we rendered it, plotting it using a package called ggplot2. There's a lot of different packages we could have done it client side, but we decided to, because there was a pretty good availability of survival packages, so we used R. So we've implemented it as a module-based report, and so as parameters change on the front end, we sort of pass that back to the server, re-render, return the artifacts, and then render it in the client. So what we LabKey report API is SVG, so we could either get SVG or PNG and render it in the client. So here's a bit of JavaScript code. Client-side implementation. So at the I've sort of snipped out parts of this to make it a little more readable. But you have the LabKey report execute. The report ID. This is how you reference module-based reports. So I have a report called survival.r. Input parameters. These are my filter parameters. Anything that I'm going to respect that I render when I'm rendering my report. And then this sort of success handler, which is the bulk of this code, sort of picks out the key value pair. I'm looking for SVG, and basically I'm just going to add it to this X panel and then render it, and remove the loading mask. So this is a pretty cool API. It's real flexible. It allows you to sort of target and get the pieces of the report that you want, and so like in an application like Argos, which is very stylized, you don't want to see the report designer or a standard view. You want just the artifacts, and you want to insert it into the page, so you get sort of a cleaner look for the user. Trade-off here, of course, going to talk about accrual estimation.
Yeah, so the second use case we want to talk about is the accrual estimation report, which is a recently developed visualization that tries to help answer the question of within my data, do I actually have enough patients to answer the question I want based on the study parameters or criteria that I want to look at. And this particular literature suggests that that's really hard to do. It's tough to do over a given time frame that you are looking to accrue your participants. Mainly because that's a very tedious process in many scenarios, because your data may be in different places. You have to check different criteria for your study based on what you're looking at. But in this particular scenario, the data is kind of all generalized or centralized in an external schema that's exposed in the LabKey server. So it allows for this visualization to do a quick kind of back-of-the-envelope estimate of, is it really feasible to do this study based on the criteria that I want to look at. So the report in this case is a box plot where the lighter colored lines, the blue lines, are on a per month basis. How many patients had their first visit? Were they accrued in that month? And the taller bars indicate kind of a cumulative total over a 12-month period. So this quickly shows kind of how many patients are we getting in a given month, and if I was looking over a year, for example, what would we maybe expect to see? And the application in this case has different ways of filtering the data based on the criteria that you're looking at. So this visualization will update as you change those parameters, and you can see which of your criteria might be more restrictive or not, or how you might need to adjust things accordingly. So this report was implemented where the data again lived in an external schema that's exposed in the LabKey server, and the query layer on the server does the aggregate or the generation of that monthly accrual data. That's then passed back down to the client to JavaScript, which uses the D3 library discussed in the LabKey visualization API, the same library that's used to generate an SVG in this case, which can then be interacted with and updated based on your various different filters applied in the application. With this, in order to implement this, we added a new bar plot geome to the LabKey visualization API. So that whole visualization you saw was generated using the LabKey visualization API. And this bar plot geome allows for different styling, display options around color and other things, but it also allows for the data input to be either individual records where the API itself will do the generation, the count of, in this case, participants for given months, or you can aggregate the data yourself on either the client side or the server side and pass that to the JavaScript geome to just generate those bar plots. So a quick example of those two differences is, here's JavaScript code that in this case I have individual data at the top that I have one record per participant and different characteristics about that participant, and there's a bar plot API that will accept this individual data, and in this case I'm telling it that I want to display based on gender, so it will handle the aggregating of that data based on that parameter and show a bar for each value in that category. Conversely, if you have already aggregated the data, which is what we did in the accrual estimation report here, the server was actually passing back the monthly counts that all the API needed to do was accept that data and build up more of a standard plot API call here, where you add different layers and geomes based on what shapes or objects you want to appear in your report. So in this case we pass in the aggregate data, and we just have to tell it which variables are the x-axis and which are the counts. So back to Carl for...
Okay, so the next case study is using Circos. So Circos, if you haven't heard about it, it is a circular visualization library. Circular visualizations are fairly interesting. A lot of times when you have a linear visualization, it's harder to establish relationships between the x-axis values. So here we have the human genome on the outer edge, and then lines that define relationships between one chromosome to another. So this was originally built for visualizing genomic data, but has been adopted for other applications. There's There was an interesting one on Wired magazine that showed sort of migration between different states, and so you had sort of states on the outside, and then it showed lines between, where people were moving from one state to the other. So if you hovered over, say, like Washington, you could see where people were moving to over a period of time. Right, and as I said before, it's effective to look at relationships between objects and positions. So one of the labs that we're working with, they're involved in gene therapy, and so they're looking at different virus vectors for delivering the therapy. And so they have a large amount of sequence data that they have loaded into a LabKey assay. They're interested in exploring Circos to see if it could help them visualize the various integration points at different points in time. So the design we use, Circos is a Perl-based tool that takes data in tabular form and an XML file for configuration. So you sort of define what types of glyphs you want, what types of plots, if there are any lines between the objects. This was basically kind of a feasibility study with the lab where they wanted to see what was possible and what would it look like if we were actually to create an application over this. So the thought was that, well, the researcher would select various runs of data. There would be a bit of UI where they could select their data of interest, parameters, what types of plots they wanted, and then they would generate the report and would invoke Circos, pick up the visualization, and display it as a report. And this type of integration, if we did it, would probably fall into the category of sort of an external tool where we would wire up an integration point with Circos as an external script engine, and so we would know how to invoke it, how to hand it configuration information, how to pick up artifacts and render it in the server. So this is kind of an example of one of the things that we built for them. So we have the genome on the outer edge. Each line, each radial line represents a compressed scatter plot. So it's a different time point for the same subject post-transplant. And each dot on the scatter plot represents an intersection point in the genome. So we don't. One of the things we talked about was maybe you can modify the glyph size based on the number of counts, so it can give you a sense of hit count or magnitude. For whatever reason, they were happy with this, but it's something that could be done via configuration file.
So the R knitter integration is less of a case study that we wanted to discuss, but just to kind of, this was knitter itself is an R package that can be used for kind of more dynamic report generation, where the writer of the report has a lot more control over the layout of the report and how it looks in relation to the report itself. And this was used by some of the groups that did a presentation yesterday. But the knitter report itself allows you to then interweave the R code that you're writing directly with HTML or Markdown. That gives you that styling as you're writing the report itself, so you don't have to pull in your R artifacts into a separate file or do things along those lines. Markdown is a kind of plain syntax or plain text syntax that allows like a wiki-like styling, and I'll show an example of an R Markdown report in a minute. But the way that this was integrated in LabKey is that the knitter package itself is installed on your R server, on your server, the way other R packages are. And there's then two options of how to create one of these reports. The first one is via the standard R report designer, where you enter in your code into the source section, and then underneath that you can turn on or off these knitter options that will tell the server to process it using the knitter package, and whether or not you're going to use HTML or Markdown in your source, and gives you the option to kind of declare your dependencies. If you're going to use external files for JavaScript or CSS, you can load those in as well. You can also then create a knitter report using a custom module report, so similar to the one that the way that Carl had implemented the survival curve as a module report, these knitter reports can be built that way as well and exposed in the LabKey server. And just to point out that knitter caching is fully supported. So the LabKey has a way of caching R reports that is slightly separate from this, in that in a knitter report the R code will always get run, but knitter itself is then decides what parts of it get cached kind of at a more lower level. And here's a quick example of what the markdown looks like in a knitter report, where at the top you see kind of syntax that's in plain text indicating the header for my report or some description, and then there's kind of code blocks of R code inside these delimiters that gets executed and can either be exposed in the report to show right next to the plot itself in this case, or it can be turned off like the setup steps at the top. So switching gears, we talked a little bit about the LabKey visualization API, so I wanted to just have a slide to kind of show the current state of that API and what different shapes and geomes are available. And then I'll do a demonstration quickly here of kind of some of the interactions that are available for how to have callback functions that are done on point click or mouse over, and some of the brushing behaviors that you can do within the D3 library using the visualization API. So the demo I'm going to show was one of the talks yesterday was about this DataSpace Collaborative Data Portal, and it's real briefly a place where different study data has been brought together to show potential relationships in data that otherwise wasn't able to be aligned or seen easily in comparison with one another. And one feature of that application is a scatter and box plot scenario where you can show relationships between different variables, but also interact with that plot to do different things like filtering your patient population set within the application the way you can by selecting specific variables in the application. So to switch over to that real quickly here, I'm going to refresh to make sure my server is still running. So here I'll discuss a little bit of the parts of the application as we go along, but I'm going to start by just selecting a Y variable that is numeric. So by default, you'll see that we are given a box plot showing the kind of distribution of those values for that particular, in this case, the 112 subjects that we have in our patient population. And this is just generated test data for this demo. But what we quickly saw was we used to be plotting the box plot and all the data points right next to it, and there was a limitation we found around, in this case, 5,000 data points, where when we put that many DOM elements onto the screen, the browser kind of had issues with allowing us to do the interactions we wanted with the plot. So we switched to this kind of binning heat map style when the data goes above that threshold, where you can still see kind of the relationships of the data, but it allows for kind of quicker interactions, where in this case, if I hover over one of the bins, you can see the number of data points in that bin, but also see which other bins share, in this case, a subject. So what other bins have at least one subject in common with the one I'm hovering over. So if I add another numeric X variable, we'll see that the plot will switch to a scatter plot, where we're going to, again, be above the threshold of how many points we wanted to display on the screen at one time. So we show binning, again, in the scatter plot case as boxes that we're rendering a lot fewer elements on the page, so the interactions are a lot smoother, where I can again do hovering over a bin to show relationships of what subjects they have in common, but also do kind of a drag brushing approach to selecting an area of the plot and again show the relationships of other bins. But also on the right hand side, you see as I did that selection, we get information about that selection, so what the values are in the region, in both the Y and the X axis that I selected, but also if I used that selection as a filter in my application, how it would affect my population of patients. So in this case, I would be down to 6 subjects if I wanted to just focus on that area. I can also clear that selection and do a selection just in one dimension. So if I wanted to select just those subjects that have at least one high CD4 count, I can make that selection and click this button over here to use that as a filter. So to switch to just subjects in that filter set, we now go below that threshold, so we switch back to showing individual data points that can be interacted in the same way with hover and brushing, and all the same interactions that we saw with the binning are now applicable to the individual data points. I can also apply filters outside of the plot that will regenerate the visualization. So if I go over here, let's say I wanted to just look at the female participants in this set of patients, I can apply that filter, and the plot will regenerate. I can also remove filters, for example, the one that I produced for the high CD4 count, and the plot kind of updates as I make other selections outside of within the application. And then a third dimension can then be added using this color variable at the top to indicate more demographic style information or other variables. So if I, in this case, say I wanted to look at the difference between my HIV infected and uninfected participants, I can select that variable and see the points change to different color and shape variables based on that interaction. So that's the demonstration. That's again all built using the LabKey visualization API, both the shapes and stuff that we rendered and the interactions around the brushing and hover and along those lines. I think that is the end of our presentation. Any questions?
Okay, thank you.
Thank you.
For our next speaker, we have a guest from De Novo Software that does FCS Express for flow cytometry analysis.
Okay, thanks everyone for your attention. My name's Kea, and as Avital said, I'm from De Novo Software. We make software for analyzing flow cytometry and image cytometry data, and the title of my talk today is Integrating FCS Express and LabKey Server for Flow and Image Cytometry Data Management. So just a little bit about us. We were founded in 1998, so we've been around for a while. And then some highlights in our company history include in the mid-2000s we launched FCS Express version 3, which includes both the research use only and the IVD version. And the IVD version of the software is the only third-party flow cytometry software registered with the FDA for in vitro diagnostic use. So we're actually the leading third-party clinical flow cytometry software package out there. By third-party, I mean non-cytometer associated, so non-acquisition driving software. But we have thousands of customers, both in the clinical, academic, and pharmaceutical realms worldwide. And then in 2011, we launched FCS Express version 4, which includes the image cytometry program, which is really neat. I'm going to show you just a little bit about it in the demo that we do for exporting the LabKey. So it allows you to analyze your image data and your flow data side by side, as if they're the same type of data. You can draw gates on plots and everything. It's really cool. And currently in development, we have FCS Express version 5, which we hope to be launching on the order of months, not years, but no solid release date yet. And we're located in Glendale, California. So what makes us different from other software packages that are out there? Firstly, we have an intuitive Microsoft Office-like interface with ribbons and tabs. So I think it's going to be pretty easy for most of you to find your way around, since we all spend a lot of time in PowerPoint and Word and everything. Sophisticated data analysis and reporting capability. What I mean by that is, in addition to all your typical dot plots and histograms and things that you need for flow data or imaging data, we can actually do regressions in the software that update as you move your gates. So scatter plots, bar plots, advanced statistics, anything that you can do in Excel, we can do in FCS Express. And in version 5, we can even do tests of significance like t-tests, chi-square, and so on. So all this allows you to quickly analyze and summarize the results of complex experiments. This is just a picture of an example of some FCS Express layouts, just to show you what I mean. So we like to say what you see is what you get. So whatever you're doing in your analysis workspace in the program, your graphical output to PDF or PowerPoint is going to look exactly like your analysis workspace. So there's no guesswork involved. So you can see that we have some plots, analyzing imaging data and flow data and advanced statistics. So there's a lot of things you can do. So why would you want to use FCS Express with LabKey Server? So what makes them go so well together? Well, the first part is what FCS Express brings to the table, which is the advanced report generation and analysis capabilities. And that goes really well with LabKey Server and its web-based data sharing environment. So, and there's flexible tools for quality control and workflow customization in the LabKey interface, which I'm sure some of you already know, which allows you to sort of combine different experiments and look at overall trends in your research that would be hard to do just using FCS Express alone and looking at one experiment at a time. Okay? So how does the integration work? Well, basically that's what I'm going to take you through the highlights of in a moment, but the overall flow is you set up your assay design in LabKey Server to receive your FCS Express data. And you can set up your FCS Express layout first and then set up your assay design in LabKey Server. It's not that, they go hand in hand. It's not that there's a defined order, but you do need to have an assay design to specifically receive your exports. And then the cool thing is the export from FCS Express to LabKey takes advantage of the built-in batch processing function of FCS Express. So the normal batch processing you would do in FCS Express to export to Excel or PowerPoint or PDF, it's that same interface, that same functionality that will allow you to export out to LabKey. So there's really, from the FCS Express side, there's nothing new you have to learn from that standpoint. And then once you're in LabKey, you can take advantage of the sophisticated data management and reporting tools there. So let's just change gears for a minute, and I'm going to go to FCS Express. So this is a very, very simple layout. There's really nothing special about it. It's not a fancy analysis, but I chose a simple layout on purpose because I just want to show you that this is an example of looking at flow data and imaging data side by side. So over here we have a typical density plot for flow data, and then down here we have, this actually didn't come off of an image cytometer, it just came off of a regular microscope, and then the results were segmented, i.e. you have object recognition, each cell is an object. That was accomplished by the freeware cell profiler, which some of you might be familiar with. We can also do that with ImageJ. So even if you don't have an AMNIS or other fancy image cytometer, if you want to start analyzing your images in a more quantitative and objective way, that's something you can do with FCS Express too. So let's just do like a quick little, I'm going to add a couple little gates here, and so that way we can have something interesting to export to LabKey. So anyway, you see the ribbon and tabs interface here, so you see it looks kind of like PowerPoint. The other thing that's like PowerPoint is we have a lot of drag and drop. So if I want to drill down on this LIMS population, I can just drag it out to make a new plot there. And let's just move that up here. And let's look at our T cells today. Maybe I'll change this to a color dot plot. Okay, and then I'm going to make some gates, just coming over to my gating tab. Call this our CD. That's our CD8 cells. Okay, let's move this down. And we can also do the same thing down here on the imaging data. So I have a gate or a marker that's drawn here on a histogram of cytoplasmic staining intensity. So what I'm going to do is just convert that histogram to a gate that I'll be able to see on the image at left. So let's call this high intensity. I'm going to give it that hot pink color so it shows up really well. So you can see on the left now we're highlighting the high intensity cytoplasmic objects. Okay, so I'm going to just move the marker around. You see that it live updates. Okay, and then if I wanted to just take a look at my data list, I have about 4 files in here. Like I said, it's a very simple experiment. I can click next and previous and just start to look at, how my data looks between each sample. So I think, now at this point we're ready to export to LabKey. So let's switch gears for a second and go to the LabKey web server interface here. And let's look at the assay design that we have currently set up before we start to line up our exports. So the name of the assay we're going to export to here is called Trial. So let's click on that. And And if I come down here to Edit Assay Design, we can see the fields that we have lined up so far. So I have a bunch of fields here. Some of these we're not going to use today, but we are going to export a percent gated stat. We're going to export a TIFF image from our layout. Let's add a couple more. So I'd like to add, let's add a ratio. Okay, so we're going to add a ratio between two gates. And then we just have to tell LabKey what is the field type here. So in this case, it's a number. And you know, if you're ever setting up an assay design in LabKey and you're not sure what the field type is, I'm sure that's something that the LabKey books can help you with. Let's add one more here. Let's add one more picture. Put a JPEG. Okay, and I'm going to do a save and close. Okay, and you know, before I actually start lining up the exports, I just want to point out that we do have tutorials that will take you through these types of steps, step by step. So, and the help is always available from within FCS Express if you come here to Contents. And I could just search for LabKey here. Okay. So, and then the first result there is basically going to take you through what I'm about to do in FCS Express step by step. So, and this tutorial also links out to the Twin LabKey tutorial, which I believe I have pulled up here, but it's coming up here. So the Twin LabKey tutorial here goes right along with the FCS Express tutorial, and it will take you through the corresponding steps in LabKey to set up your assay design. Okay? So, but let's just go ahead and set that up. So that's going to be here on my batch tab. And when I pull up these batch actions, you see that we have a whole bunch of things we can add. Okay, so we can add, for instance, a PowerPoint export. We could actually add a print. Let's just close that help so it gets out of the way there. Sorry. So we could add a print, and we'd have a printout of our page that looks exactly like our analysis in FCS Express. I'm going to uncheck that because I'm not actually hooked up to a printer. But let's add a PowerPoint as well, and we'll send this to our desktop. And finally, of course, let's add the LabKey action right here. And when you add the LabKey action, you're faced with this window, and now we have to go into LabKey and get the LabKey server URL and the protocol ID. So LabKey, so it's sent to the right place in the LabKey server. So I'll just come back to my assay design here and come over to import data, which has that information. Okay, so that's our server URL, and then our protocol ID right here is 10, so we'll just type that in manually. Okay, and here you can give a descriptive name if you want, so we'll just call it our experiment, and let's put this as our comment. And then this is where you would type in your LabKey username and password. All right, so now we just have to tell LabKey what we're exporting, and that's again by drag and drop. It's very easy. So if I want to drag over this LIMS gate, I can drag that in like this, and we just need to come over here to field and type in the name of the field that we defined in the LabKey assay design. So this one was called %. Whoops. Forgot to select a statistic that's here. We'll do % of gated cells. We can add in a picture. All right, so let's put in our JPEG, and we can put in, let's see, we'll put in this one, okay? And let's see, we also wanted to put in a ratio, right? So this is kind of nice. So if you want to do something like a CD4 or CD8 ratio, you can do that right here in FCS Express. You don't need to go out to Excel or pull out your calculator to do that. So we'll just set that up really quick. And that's actually works very similar to Excel. So we'll just name the ratio here. And so just to show you, like, this works the exact same way you would type a ratio in Excel. So if I wanted to type equals 20 divided by 4 and drag that out, you'd see there it's evaluated as 5, but rather than dividing two numerals, I'm actually going to divide the two gates by each other. So I'll drag my CD4 gate over here, and we'll divide the number of events there by the number of events in CD8. Okay, and so you see there it's updated as 0.21, and of course that's going to update if you move your gate around. We can even add some text here so we know what we're looking at. And this is like I said, it's a really simple layout. You could actually make this look really nice and have very nice professional looking formatted text tables, but we're just keeping it simple for today. So now I'm going to drag this ratio over because we're going to export that to LabKey. And we just need to come over here into field and give it in the XML node that name that we defined in the assay design. So we named it ratio. Okay. So let's do a save there. All right, so we're pretty much ready to go. When I click run on the batch tab, it's going to send everything out to LabKey, and it's also going to generate that PowerPoint export, which is the whole results of our layout. Okay. And just to mention, there's other file types you can export to LabKey. I think pretty much any file type, if I'm not mistaken. So we could export the layout itself, raw FCS files, whatever you would need to export to LabKey server you can do. But we're just doing these 3 for today. All right, so I am going to click run. Okay, so it's stopping as it got to the next sample and giving me a chance to adjust my gates. So, you know, anything you want to do, even if you want to make this gate really large. I know that doesn't make sense, but just to see that it comes through in the PowerPoint, I'm making a few obvious changes here. Okay, so I'm just going to continue because I think you get the general idea. Okay. Should be exporting soon. I think I'm getting a little bit of a hang. Okay, we can come back to that. That's the PowerPoint, but let's go to the LabKey results now. And we can actually look at a list of all the previous runs of this assay. So we're clicking on view runs here, and you see all the previous times that we've run this. Let's see, I'm not sure if it's... It's interesting. I just ran this, not sure why that didn't go. I do have a previous run that we exported earlier with all the similar results there. So anyway, here you can see that we exported some TIFFs, and then the percent is there. The ratio field from that past run isn't there, but we can just open that up and see that the TIFFs worked. Okay, so there's one of the TIFFs that we exported. So I'll just come back to the talk. Okay, so what can you do with your data now that it is in LabKey? You can export your data from LabKey to Excel, to text reports, also to tools like R or scripts. And you can even, as you've seen from the previous talk, combine selected results together from different experiments. So this is an example of analysis that's being done between 2 experiments here, where basically you have one set of experiments that has this viral load parameter, and the first set doesn't have it and the second set does. So you can combine the results of multiple and disparate experiments and analyze those in LabKey. And you have the ability to generate graphs in LabKey, so this is a nice looking scatter plot. You can see clearly that this is 2 completely different experiments that have been combined. So the first one here only has data up to, I think, about day 3 or 4. It's hard to see the axes labels there, whereas most of this data stretches on beyond 20 months rather. And you also have the ability to filter results on user-defined criteria. So here, the filter has been applied to these specific treatment groups. So just in summary, FCS Express and LabKey Server allows you to combine the analysis and reporting capability of FCS Express with the sophisticated web-based environment of LabKey Server. And we have those joint tutorials which I showed you that can help you get started. Or you can email us at support@denovosoftware.com and we can help you get started designing your layout in FCS Express. And visit our website too to learn more information. So, okay, thanks very much.
Thanks, Kia.
Hi everyone, I did the live demo with FCS Express and LabKey, and I just wanted to mention that I tracked down the source of the error. The source of the error was me. I forgot to enter in the name of a data field into the XML node of the batch processing function of FCS Express, so I just wanted to show you that everything's functioning as expected, both on the FCS Express side and of course the LabKey side. So I'll definitely be around through lunch if any of you want to chat about possibly integrating your flow data into LabKey, because of course you can then cross-reference it with other kinds of data like MS or mouse studies, what have you. I'll be around and happy to chat with you and show you that the assay really did work. So I apologize for my demo not working. That's what I get for daring to do a live demo. Never again, right? Sorry.
A little bit of background is we do clinical trials management. We're funded by NIH through NIAID and other organizations like the Type 1 Diabetes Foundation. And our mandate is basically to help the primary investigators and scientists put together their studies, do some of the analysis if they don't have that in-house with our biostats, especially help with the specimen management and everything. And so we chose LabKey a long time ago because it does both of those things. It can do your specimen management and your mechanistic data and so forth. I wrote, we're jumping the gun, but since I don't have any good screenshots to show you, I thought we'd go ahead and use some cheesy Photoshop graphics. So our issue was that we had two cases, one for data sets and one for specimens, and the differences between those is that the specimens, we want those to refresh every night. All our different repositories send us specimen. Okay. Send us specimen data every night. They come in different formats from those labs. We have to reconcile those formats, and then we also have to make sure they're clean, make sure they can go in. We do not use LabKey as the database of record for the specimens. It's only showing the specimen levels to the users, and then they can request them. But the actual database of record is separate from that because we have other software to deal with that specifically. So we wanted a way to load the specimens into LabKey every night based on the latest data image from the database of record. And then on the data set side, that doesn't need to happen every night. That only needs to happen when we're setting up a study or if there's a change or a new data set. So we wanted that to be schedulable too, but we also wanted to be able to do any of this on demand. We didn't want any downtime, so we never wanted to shut down Tomcat or lock it up. So here's a little bit of telemetry on the kind of data that we're dealing with. We got 5.3 million rows of data and 4,000 data sets or so. And then right now we're at 400,000 specimens that need to be loaded every night. And that goes up pretty quickly. We're adding more studies all the time. And then this stuff I already covered. You can see also with data sets, I'm sure you guys, it was a recurring theme yesterday about the way that when you get the data, it's not always in the format that you want, and DTAs are just something that people, kind of nod and say, oh, sure, yeah, without really understanding the implications of DTAs and things in an automated system. So what we use is we use a staging server and a production server. And I'm going to go ahead and say if you don't do that, do it, because VMs are cheap, installations of LabKey are free. So have a staging server so that it can do some of the work before you put it on your production server, if your production server is facing the world especially. So here are some of the different requirements that we felt like we had. As you can see, we use the API, and what we did I'm not going to go through each one of these, but you can see some of them. We don't want to shut off Tomcat, like I said. We covered most of this. We want to let the administrators know what's happened. It should be easy for an administrator to see what happened when it went right and when it went wrong. So that's some of that. Now, what we decided to do was, we decided rather than using the pipeline jobs existing in LabKey, that what we wanted to do is we wanted to stick with the file-based study package. And if any of you are familiar with that, it's just a package of XML and TSVs and everything like that, defining your data, and then some XML configuration files telling you about how the study is structured. And the nice thing about keeping it in the file system is that it's very portable. It's very easy to back up because you can just take what you've got existing and just zip it up and just set it off to the side. So Biocat, it's a Java web application using all open source technologies, tried and true, Spring MVC3, Quartz scheduling, it's a good framework for that. We run on Tomcat 7, Hibernate 3 for the persistent side, for the models of these studies, and not the data from the studies, but their scheduling events and things like that, their paths, their study names. We have a little HyperSQL database, which is very lightweight, lives on the same file system, so it's nice and fast. Biocat basically does what I said, creates and manipulates pipeline files, in the study packages, and then calls LabKey server when it wants data sets or specimens reloaded. Knockout Mouse is the part of it that handles validation and notification. There's many different things that can go wrong with the data when you're reading somebody else's database. I keep thinking that I found all the different ways. Some warnings will come in, we'll find that the ETL, this has only happened once, so not some warning. And this was in the early stages before I had thought to put in that validation, and the entire table was empty. And the very first pre-alpha version of this program happily ran and loaded up empty specimens to our staging server. And it's a good thing it was the staging server, because it completely wiped out, pretty much all of our specimens. But, again, staging server, so we were able to fix the problem, run it again, and never put that on production. A couple of technologies that I really like, especially if you're a small development group, is it has one-click deployment with some technologies that I can tell you about. I'm just a total evangelist on Gradle and Cargo, which is, does anybody use Ant or other build tools? Okay. Basically, it just puts your software together and then deploys it and stuff. And this is just a different way to do that without XML. Cargo is a little sub-part of that, a framework that will go out and it'll stop your Tomcat server if it needs to. It'll redeploy your program. It'll start Tomcat again for you, all from the IDE. Just click the play button and wham, you can send it all the way from, in our case, DC to Seattle to see what it's going to do. This is a brief diagram that I'm not going to go through. Look at it at your leisure or talk to me about it. It just shows the different steps that happen with data sets coming in, specimens coming in, and just some of the different things we do that go or no-go files depending on whether there was an issue. And then in the middle are the validations, some of the validations that we decided need to be made once we've got it on the staging server. One thing that Biocat does lately, which is pretty clever, is that it actually goes and it talks to the staging server after the load is made and sees what it looks like there. It asks LabKey, well, how many participants do you have in this study? Because one thing that can happen is, because LabKey develops the list of participants on the fly. It's not based on your demographics data set. If you bring in specimens and those have new PTIDs that aren't in the study already, it will add those PTIDs, and sometimes that isn't what you want to do. Sometimes the lab that gave you the data, they've changed, their formatting or something like that. So now you want to ask that staging server, hey, we had 200 participants yesterday, we've got 400 participants today. We should probably look at that, because that probably wasn't what we meant to do. And again, the whole idea, do it on staging. Ask anything programmatically that you can, because otherwise you're relying on somebody putting eyes on the staging server every single day. The plans for it, we're going to open source the whole thing. I'm going to try to break it into discrete packages, the front end, the data set part, the specimen part, because I don't think that anybody's going to want to take this whole thing the way it is and use it on their system, because it's too specific to us. But that being said, the different parts of it I think will be really useful to people. and also just maybe as just a learning tool about how the really low-level parts of specimen and dataset loading and LabKey work. We definitely want to do more pre-staging validation. There's always new questions to ask, global and study-specific options. What we do when we do data sets or specimens, if we're only doing one of those, what we do is we set aside a copy of the study XML, which has the entire definition, and if you load that in, it'll do data sets and specimens, so you can programmatically pull out elements and say, okay, pull out the data sets, pull out the cohorts information, pull out everything except, say, specimens. And then when LabKey reloads that study, we'll only do the specimens, which is good because a lot of times you don't want to reload your data sets. You don't want to redo your cohorts, especially if you have custom stuff done with them. There is rollback already, but it's just zip files that we store, so we want to be able to do that via the UI. Testing, most of my projects nowadays I use Cucumber and Gherkin, and this is one of the most exciting things out there if you're a programmer and you also gather requirements. That was the one-click deployment. But Cucumber and Gherkin, what you can do here is if you look down here, you can gather your requirements, or they're your own requirements that you know should happen in the program. So what you can do is say something like, type a sentence in English. When the user called document toolkit update with parameters, put your parameters in a string and an array of bytes, yada, yada, yada. Okay, and then you just kind of right-click here, Alt-Enter or whatever, and what it does, it actually makes you this method. And it saw a string here, so it's going to put string. You're going to name it. You can see this is actually the same sentence, just kind of formatted. And then you write in here what you want to do. So you can start writing your program from here. You go in, you gather your requirements. As they're telling you what they want, you write things, scenarios, you write given, when, then statements on the fly as they're doing it. And you just go sit down at your computer and type those in, and then you just start filling this out. And that's it. And once you're done, you've got your testing done already. Your specimen and testing was all done in one step. Because what you do is once you've got these, you click test, and it's going to go through here. And if you change your code and all of a sudden this second step doesn't work, it'll tell you that. And it's going to, so you know exactly where to go. So this is great. I mean, it's just a giant time saver over using different technologies like JUnit and et cetera, and then having specimens, requirements gathering completely separate. It saved me literally, I don't know, a month of time in the last year. So anyway, there's our contact information, more cheesy Photoshop stuff. Any questions? Okay.
Out of curiosity, how long does it take you to load the 400K specimen?
Right now, 34 minutes. And that's only because I have them spaced out a little bit. We need to go back in and bring them closer. So I'm guessing it's probably going to be more like 20 minutes or something like that on the production server. But we've worked really hard with our sister organization who hosts our VMs. So we've got like, I think, 48 gigs of RAM, 16 cores, on the database and the LabKey server on the same physical machine, so there's no latency. Because right now, unfortunately, in LabKey, when you're loading specimens for one study, in our configuration, it locks out the specimens for all the studies. And we have a lot of international users, and they're coming in all times of the night. And if they come in and they want to go to our public studies and look at specimens and they aren't there, are they going to come back? And so LabKey has just recently discovered how to solve that problem, so only one study is down at a time. Okay, thank you.
Next, we have Tom Hudson from Novo Nordisk. He will talk about using LabKey server to manage daily activities of complex animal studies.
Thanks. I'm Tom Hudson. I'm at Novo Nordisk here in Seattle, and I want to talk a little bit about how I'm using LabKey to manage the daily activities of some of our complex animal studies. And I want to start by giving an example of a really simple animal model in which you might start by inducing disease in your animals, dividing them into two groups. One group gets a test treatment, the other group gets a control treatment, and then you take some kind of measurement that you're using to determine efficacy, and then at the end you would plot your results maybe in a bar graph or in a Kaplan-Meier curve, and you can run statistics and get your result. That's a pretty easy study, and that can be done in Excel or even really by paper. But the studies I'm working on now in T1D are much more complicated. Before I get into the studies, I'll talk a little bit about our research area. So type 1 diabetes is the autoimmune version of diabetes, and it has a genetic component. It's most commonly associated with children, but it can be diagnosed at any age. And there are current treatments that can manage the disease, but there is no current cure. So that's really what we're working on at Novo Nordisk, is to cure the disease. So the animal model we use to study type 1 diabetes is the non-obese diabetic mouse, or the NOD mouse. And these mice spontaneously develop diabetes as early as 3 to 4 weeks of age and as late as a year old or even later. And one of our goals is to test if our candidate treatments can reverse or cure diabetes in these mice once they've already got the disease. So this is not a prevention study. We're actually trying to reverse or cure the disease. And so in our mice, we define disease onset as having a blood glucose value, or BGV, above a certain threshold. And we screen all of our mice twice a week to see if they have become diabetic and can potentially become enrolled in the study. So I have a diagram of our typical studies. So the mice arrive at about 10 weeks of age, and we screen their BGV twice a week. We happen to do it on Mondays and Thursdays. And we do this until the mice reach 30 weeks of age, at which point we end the enrollment period. And as the mice become diabetic, we will confirm with the second reading that they are indeed diabetic, and then we can enroll them into one of our treatment groups. Now, for our study, we're actually testing 2 drugs in combination. So it gets a little bit more complicated. So we have 2 test drugs, and then we obviously need 2 control drugs as well, which means we have a total of 4 groups. One group gets both of the test drugs, one group gets both of the control groups, and then there's 2 groups that get one test drug and 1 control drug. And here's what the dosing schedule looks like for these. Drug 1 or control 1, which are the orange, or I should say red and yellow lines here, that's given every single day throughout the course of the study. And it's dosed in a weight-dependent manner, so we also have to weigh the mice. That's represented by the purple stars. And we can't give this drug at the full dose on the first treatment, so we also have to ramp up the drugs. So on day 1 it'll get formulation A, day 2 it'll get formulation B, and day 3 onward it gets formulation C, and onward. And so for our second drug or control, we give just 4 doses of that, and that's given twice a week on Tuesdays and Thursdays. And the point I'm trying to make is that it's fairly complicated. It's much easier than just a single vaccine and then see what happens. As the mice become, or during the study, if any of the mice become too diabetic, where their BGV becomes too high, we'll have to euthanize it for welfare reasons. And then as each mice in a group reaches 35 days of treatment, we'll collect a final BGV, and we'll euthanize the mouse and collect any samples that we might want to do any assays on. And then at the end, we'll do some graphing, and I'll get back into graphing in a little bit. But I want to stress really that this is one timeline, but we actually have a different timeline for each mouse because they're all becoming diabetic at different times. So it's not just 1 or 2 patients to keep track of. We have 160 animals in this study. So it's kind of like a phase 2 clinical trial. And on any given day, we need to know which mice need which treatments and how much of it. And this is done by one person, so it's pretty complicated. And so certainly there was a problem here that we were hoping to solve. I do want to talk about the measures of efficacy we use for our studies. We're looking at BGV versus day post-onset or day post-enrollment. Those are those graphs on the left. So in those graphs, mice that drop below that BGV threshold, which is the blue line, those mice are considered cured. And mice that remain above that blue threshold are considered still diabetic. And we also use Kaplan-Meier curves to look at diabetes reversal. All the mice are diabetic at day 0, and hopefully, at least in the treatment groups, they'll revert to a non-diabetic status throughout the course of the study. So we were implementing LabKey in our lab, mostly as a data repository and for analysis. But I thought maybe we can use this to help manage our studies. And I wanted to create a system whereby one person could manage the study easily, much easier than we were doing before anyway. And I wanted to be able to create reports from LabKey that we could print out and bring to our animal facility every day and use as work lists, so we knew exactly what we needed to do and which drugs to give to which mice. Those reports also were going to require some empty columns so that we could record new data. Hannah was mentioning yesterday that you don't have computers in the TC. We also don't have computers in our animal facility, or at least not that are easily accessible, so it's important to be able to write things down. The reports always need to be up to date because there's a lot of moving parts, as you can imagine, and we want to make sure that multiple people can be accessing this study. We were previously using Excel, and if more than one person tries to open an Excel file, you run into problems. We also had a binder we were using for a while, and if the binder was not where you were expecting, then you couldn't do anything. And also, I was hoping to automate all of this so that nothing would be missed in our daily workflow, and that no work was duplicated. And of course, we also wanted to visualize the data within LabKey. So John Rue was talking yesterday about how we have integrated Easy Colony, which is our mouse colony database, into LabKey. And so LabKey can pull our demographic data set directly from Easy Colony. And so even if we are moving mice around into new cages or whatever, we always have that updated information in LabKey, and that makes it much easier to make sure that our reports are always up to date and accurate. In order to make those treatment reports that I was talking about, I had to teach myself a little SQL. I really have no experience with coding, but John Rue gave me some access to the back end. And so I used some queries to make some calculated columns that would tell you whether a mouse needed a particular drug, and if so, which formulation of that drug on any given day. And case 1 statements were really useful to help determine this. And that the current date function or variable really makes sure that the reports are dynamic. And so the report's going to reflect on any given day the treatments that are necessary for that specific day without having to make any manual changes. And the code down here is just an example of some really basic SQL that will determine which formulation of one of our drugs a mouse will need depending on how long it's been enrolled in the study. So this is that drug 1 where if it's its first day in the study, it'll get formulation A. If it's second day, it gets formulation B. Otherwise, it'll get formulation C. So once I designed some SQL queries, I used the custom views to help filter out mice that I didn't need to display in the reports, especially those mice that had already been euthanized, because we don't want people running around looking for mice that don't exist anymore. And we wanted to sort the animals so that they're displayed in the same order that we would find them in the vivarium. Because if any of you have worked in an animal facility before, you know there's a lot of glove changes and disinfecting, and you want to make sure that your report is in a way that's going to make sense and save you a lot of time. So on Mondays and Thursdays, those are the days that we go down into our animal facility and we're screening the BGV of all of our animals. And so I wanted to have reports so that each person could just print out a report of the mice that they were responsible for, and they'd be able to fill in the new data. Also, they'd be able to treat the animals if they needed treatment. And that way, no work would get missed and nothing was duplicated. And so here's an example of what we go through on one of those days. So everyone can log into LabKey. They can open this report and use the views drop down to choose the view specific just for them, and it'll list just the animals that they're responsible for. And then we export it into Excel and do a little formatting just to make it a little bit more user-friendly. And so here the mice are sorted by cage. There's an empty column so we can record the BGV, because remember we're printing this out and bringing it into the animal facility. It also shows which group each of the mice are enrolled in, if they're enrolled. It shows how much the mice weigh, which is really important for dosing. And it tells you which drug formulation the animal will need. And again, that's based on how many days it's been enrolled in the study. So this is all automated. And I don't have to do anything any day except for just print the report. And that's already ready for us. So that's what we're doing on Mondays and Thursdays when we're screening the mice for their BGV. The other days of the week, we're still administering treatments. As I had mentioned, our study has 2 different drugs. One drug is given every single day throughout the course of the study, whereas the second drug we only give on Tuesdays and Fridays because it's a bit complicated to dose, and so we try to only do it on those 2 days. And it's only for 4 doses, and we need to make sure that it's exactly 4 doses for all the animals. And so what I created was a single dynamic treatment report that takes the current date and the day of the week into account, so that will show the correct treatments for that day. So here's an example of one of those treatment reports. And again, it's sorted by cage to make things a little bit more efficient when you're in an animal facility. And again, it shows the current weight for dosing calculations. For that first drug, it shows which formulation you need, and it's color-coded. And again, that's based on how many days it's been enrolled. That second drug, there's only one formulation, so it's just a true or false as to whether or not you need to administer the drug to that mouse on that day. So to enroll the animals, we have to have 2 back-to-back diabetic readings, because we want to make sure that they're truly diabetic and the first reading just wasn't a one-off thing. And so I have a tab built within the study that I have designed just to print directly from the browser to help on days when I'm going to be confirming animals and possibly enrolling them. The first part has, it lists mice that had a BGV above our threshold on the previous day. And then there's also some blank columns here. Those are always blank. And so when we print them out, I can write in the new BGV for those mice. And if they qualify, I can write in which group I've assigned it to. And the bottom part, it lists the groups and the order in which the mice should be enrolled. And that's based on when the most recent mice were enrolled into the groups and how many mice are in each group, and it just keeps things balanced. And over on the right, there are some live statistics for those groups. One thing we want to be careful about is that the average BGV at onset is similar between the groups. Because if one group has a higher BGV at onset, that means that that group is getting sicker mice from the start. So that's going to confound the data at the end if that treatment maybe didn't work. Is it because the mice were sicker to begin with, or was it because it didn't work? So we had that happen before. Now we can monitor the randomization live and make any adjustments on the fly if we need to. So the impact on our workflow is that the study is a lot easier to manage now than it was previously. Far fewer mistakes are made with dosing because these reports aren't done manually anymore. And when we were doing these reports manually, it was taking as long as an hour a day just to figure out which mice were going to need which treatments before we even got down into our animal facility. And now it takes only as long as it takes to log into LabKey and print a report. And so there was that initial investment to set up the study in LabKey, but it's really been worth it. It's definitely been time saved overall. Multiple people can access the study at the same time now. There's no lockouts with Excel, and we don't have that one massive binder that was always going missing. And the automation of the reports means that any user can take over when I'm not there. So I can actually go on vacation, and I can come talk to you at conferences. And they know exactly what they need to do, and it's much more straightforward now. Before, when someone was sick, it was a nightmare. No one knew what to do, and there was going to be a problem every single time. So overall, the consistency of our data and work has been greatly improved. I do want to talk a little bit about our data visualization. We have a pivot table in this study now that shows BGV versus day post-onset or post-enrollment. And there's a color scale here, so the more diabetic the blood glucose value, the more dark red it is. And so it's really easy to visualize what's going on in each group. Also, I have these BGV graphs. These we used to do in Prism, and we would be taking data from Excel, reformatting it for Prism since it takes a fairly specific format, and then making the graphs. And that takes a bunch of time, and my boss in particular wanted updates every other day, it seemed. And so having them in LabKey now just means that they're always available and they're always up to date, and there's no mistakes because it's tied directly to the database. We're also working on getting our Kaplan-Meier curves built into the studies as well. These are really the most important graphs for each of our studies because these are how we decide whether or not we're going to bring a drug forward or abandon it. So having it directly in LabKey makes it easier and faster to report the data and to make those decisions. And although we are doing some of those BGV graphs directly in LabKey now, there's always going to be some analysis that we're going to do in GraphPad Prism. And so I made a view that formats the data exactly the way GraphPad Prism wants. If you've worked with Prism, you know that this is kind of the format you want. So by having this just it just stays updated in the way that Prism wants, I can export it and copy it directly into Prism and go on with some analysis. For instance, my boss likes to look at subgroup effects. So that's a lot faster now. I won't get into the other data going into LabKey because John Rue did a good job of explaining what we're doing at Novo yesterday. But I just want to point out that you can use LabKey to actually manage the daily activities of complex animal studies. And so I'll put up my acknowledgement slide and see if anyone has any questions. All right. Thank you.
Just maybe a quick question.
So what I'm going to talk about for this presentation is I wanted to just see how many people update every time LabKey comes with a new version. Not developers. So in our case, what we do in the Wisconsin Primate Research Center, we use the LabKey to manage the health information and also research data for all of the animals that we have. So the staff in the center use this on a regular basis to upload data, to decide on treatments, to decide on different, to search for animals. And so basically they use the system on a day-to-day basis, and they cannot do their job if the system is not up. So what some of the roles that I have is to, with every version of LabKey, to make sure it works. Everything that we use works the way it was planned. So that turns out that a lot of the times we don't update to the latest version because some of the things in the background just don't work as we had designed originally. So so some feedback, some background about the Wisconsin National Primate Research Center. So our mission is to increase our understanding of basic biology and to improve human health and quality on quality of life through research. So we are one of 7 NIH-funded, nationally funded primate centers. We maintain 3 colonies of animals, roughly 1,400 animals. As I was telling you before, we use LabKey to store and monitor health of non-human primates. And the system is used on a day-to-day basis. So anytime that the system is down, well, basically the system cannot be down ever. Otherwise, I get very angry users. So in order to give you a little bit more background, you have to understand your users. Who are your users? So on average, we have 114 people that use the system per day. Some days, we have more use. People log in like 300 to 400 times a day to the system to figure out what do they need. Also, the type of users that we have, not all of them are researchers, so we have a wide variety of computer literacy within our staff. So some people are animal care staff that, they use the system to upload data, collect weights. When you have researchers that query the data, get information from the system. You also have veterinarians that use the system to make health decisions about how to treat the animals in case they get sick or something. So the general uses of the system is upload and search for data, store and retrieve biomedical information. One of the big things is select animals for different research projects. So if you're interested in learning about diabetes, you might search animals that are older than this age and have diabetes on the record. And also, as I was telling you before, it's used to perform activities on a daily basis. So again, as I was pointing out in the beginning of the talk, is LabKey updates 3 times a year. So in our center, we strive for stability, so we need a system that is robust and always on. So we cannot do that. We cannot update every 3 times a year because it's used for daily management of the primate colony. Also, if as a developer and administrator, some of the features that how people use LabKey, but at the end it's the users who know it best. My animal care staff, they are the ones that use the system, and if it gives them a problem or it doesn't behave the same way,
they will let me know. The other part of it is that LabKey has a set of automatic tests that run on every single update or on any commit to the SVN. But a lot of the times, simulating workflow, so like, how two units will use the system, the research arm will schedule blood draws, and then the animal care staff will go and take those blood draws. Communicating using the system sometimes it's difficult to capture that in a workflow or an automatic way, mimicking the workflow of the units. So one of the things that we try was, every time we do an update, just send an email to a subset of users and ask them, please, try it out, the staging server, try to break it, report back to us. The problem is that usually people get overwhelmed and they're like, I don't know what to do, like, how can what are the tasks that I need to do in order to make sure the system works? So in one of the release talks on the LabKey that has on a regular basis, I learned about the survey module that it was developed for other project. So I was like, oh, that is a very interesting feature that we can potentially use it. So that is one of the things that kind of has resonated with this conference, is that some of the things that other people build or develop through the open source framework, us can use without much, tweaking it a little bit. We can use it for our own benefit. So it's an ecosystem that something that I develop might work for somebody else. So we set up a small survey, and we have a set of asking the right questions to our users so that they know how to. They provide us the information that we're looking for. And also, one of the things that we recently implemented was, after they provide us all the problems that they found, be able to report back to them what is the status on the fixes. Because one thing is they tell you, like, a laundry list of all the problems they found, but there should be some accountability from our side saying, like, hey, what you reported, we fixed it. Can you please try it again and make sure it works? So this is we worked for quite a while to come down to a set of questions that will be generic enough that can guide people through the different type of uses of the LabKey system. So the first set of questions are for retrieving data. So if I'm interested in looking for a particular animal, can people do this? The other set of questions is querying the data. So I'm interested in a cohort of this type of study. So are you able to query the system? Also, data input. That's the other part that we use LabKey on a daily basis for uploading data. And the compliance and uninterested stuff. Do you have the correct access? Do you have access to read your SOPs and do other type of things? So one of the key things is making the questions clear enough so that people know what to do. So setting up a survey. I don't know how many people have used this feature of LabKey. No? Josh, you have done a lot of things. Well, and thanks to Josh and Corey, I think he helped us set it up a couple years back. The nice thing is that you can just reuse it. Every time we do an update, we set up the questions, we set up the survey, and we keep reusing the same list. So first, you create a list to store all your responses. This could either be a data set or a list. With a list, it works a little bit easier, but I can see potentially if you are interested in, yesterday somebody was saying that they were going to use RedCap to capture information from the field. You can potentially set up a very simple survey, send a link to people, and have them answer the questions, and that data will go directly into a data set that you can use. So one of the things is you have to set it up in a folder. We usually, the way we set it up is in a public folder that has, that people will have editor access to that folder. Develop the questions and the survey structure. And, in particular, because people are not willing to spend like 3 hours testing the new version, we set it up very simple using drop-downs, free text entry, so that if it works, they can give us quick feedback on what is working and what is not working. Some considerations to add it as a developer. Sometimes I also like to see the screenshots, like if it's not working, show me what is happening or what is the problem that you're encountering. So that potentially can be included. We don't have that right now. So this takes a while to set it up. I mean, it works, but once you have set it up, as I said, you can reuse it very easily. So the whole survey, you have to enable the survey module. It is a JSON type of query or text. You have to define, match it to your predefined list, so that everything that is entered gets associated with the correct field in your list. LabKey provides some examples of the things that you can use. So you can use a checkbox, a combo box, the different numbers that you can use. You can use a grid. We mainly focus on free text and combo boxes in the survey that we develop. So this is how the survey, the end result looks like. So you can see it's cut off, but you set up a survey label or a name. You ask the person to put their information. Potentially you can set it up so that automatically fills it up with their user ID. And then you guide them through the type of questions that you're interested in. These are live links that basically, if people click here, will send them to the place that you want them to check, or basically you walk them through the testing procedure. And the nice thing about it is that people don't have to set it up in one seat or like in one session. So they can save it, and come back in the next day or an hour later when they have time and complete it. It's not until they submit complete form that they cannot edit it anymore, or they cannot change. They can change it, but it's a little bit more difficult to change. So one of the things that we have learned, specifically with the latest test, is once you send the survey and you're ready to test, don't change anything during end user testing. It creates a sometimes it might, people are giving you feedback of a problem, of a bigger problem, because you're changing, not because of the new version. So we encounter that. Give users ample time to complete the survey. These are people that do not have time to, they're trying to get through the day, giving all the procedures, doing everything. Give ample time to your users to complete the survey. Get support from senior management, either by having them send a reminder email, letting them know, please do this, or asking them for time away from their employees' daily activities. And what I was telling you this last time, provide feedback to your users about the problems they reported. So this is a very simple wiki that we set up. The number of problems reported by unit and how many we have already solved. So there's kind of like a progress report that we can let people know this is what we're doing. I can let you see how this works. It's pretty simple, or it's pretty straightforward. So here's the survey module, or here's the what people come up to. Just very basic set of instructions. If they want to create a new survey, they go here, create a new survey. It automatically generates a new one. They fill in the data that they are looking for, and they save they go down here and save or submit a completed form. The links are very nice because, if you click here, automatically sends you to, well, it's going to the live server, to the test server. So it takes you directly to the place within your system to have them test. So, like, can you do animal search? Can you search by location? Can you see the clinical tab? And and you're trying to see if they see differences on the columns that you're displaying. A couple versions back, we were having some issues with the number of decimal points. So a lot of our values were calculated with a lot of decimal points. So people say I don't want to see 20 decimal points. I just want to see 3 decimal points. So, and then, as I was telling you, this is one that I was working on before, just before the talk. So I can go back to it. Oh, no, that is not it. Sorry. So this one is one that I was working before. I can go back to it and, complete, say, does it work? No. Testing. So it automatically, saves the data. One of the nice features of this is that you can go into the list view and see all your responses at once, so that you can see kind of like a summarized version of it. So that's, I think I have all the time I have. How are we doing on time? Okay. So any questions?
Do you target specific users for this testing, or is it just kind of a free-for-all?
Yes, we do target. So we have a set of what we call power users that their unit heads have decided that you have the privilege to test the new versions of LabKey. So they don't like me so much sometimes. They do like me sometimes because they want to make sure at least for their unit perspective, the system is working the way they use it. So that cohort of users, those are the ones that are willing to spend the time and give you some feedback.
So could you go over the rationale why? It seems like it almost take you more time to develop this survey than to do these tests yourself.
Yes, potentially, but the system that we have it's the way we use it is relatively big. So I have animal caretakers that use the system for one way. I have researchers that use the system in another way. So for me to test every single feature, is this column showing the right way, or the order of the columns is doing the right way? We do some testing, so we do some testing, I do some testing before every update, but I cannot test every single feature or any little discrepancies between versions. That is when the users can actually tell me that. By the way, the number of decimals is too many in this particular calculation. So in that's, I rely on my end users to give me those little details. From a automatic point of view, the system says, yeah, you can enter data, but how does the data display? How is it behaving the same way as the previous version? So we do tests. We try to do most of the thorough tests before we send this survey. So this is kind of like the last step before we do an update. So we rely on LabKey to do some of the automatic tests. Then we have a couple of developers do our side of the test, and then once we know that the system is working pretty well, we send it to our user just to make sure nothing is dramatically broken. Once we set it up, as I said, we can reuse the same survey. We might add a new question or something, but it's pretty straightforward how to set it up from version to version.
Have you done is there any way to integrate it? I assume there would be with
the mail system that's kind of built into LabKey to, like I was thinking we use U-Track and you can set it up to email something to that tracking management system and it will automatically create an issue. So I mean, this was very interesting. I'm just wondering.
It would be possible to hook in, you know, a little bit of script, for example, to send a mail or hook it to some other server, or, you know, do that kind of integration.
Or the lab issue tracker would be the console too.
Sure.
So I think at one point we did, like, so the other way that we tried it before was using the issue tracker. You know, like, you know, like send a general email to our power users and say, like, please test this test version and tell us what happens. But the problem with that is that users get overwhelmed. They're like, I don't know what I'm supposed to test. You know, am I supposed to put real data here or fake data? So this allows them, it's a way to guide them through the testing process, you know, using some of the features that LabKey already has.
Just one follow-up. You said that it had to have public, it had to be in a public study where the users have editor permissions. Does that have any implications outside of the survey?
So it wouldn't need to be a true public thing. The user submitting data would need permission to insert that survey data, basically.
Oh, okay, and that can be like just specifically to be able to do that one thing?
That could be open to only those users, for example, yeah.
Would that be submitter or editor? Be doing submitter? Because I actually just locked down my support board because I found that people were actually creating wiki pages.
Yeah. I don't know for sure that submitter would work as is, but I think it would be a small thing to
Yeah, I think this time we tested only with submitters because I was also afraid of that. So just basically this is a public folder within the IT subfolder. So like within a IT folder we have a public that any user has access. And I think we try as just submitter because I was like, well, I don't want people creating new wikis and doing, or editing. So the other problem that I was looking at, going to another user's feedback and, you know, erasing it or editing, putting stupid things, you know, you never know what your users are going to do. So I was trying to restrict, but we ran into the problem that you have to have editor access. So that, as a user, allows you to edit somebody else's comments. But it might be a problem, you know, we haven't encountered it yet. The feedback that I get from users is very thorough, and, you know, people really tell you what is not working.
For the final presentation of this morning, I'm going to talk a little bit more about the R pipelines for RNA-seq data. So Raphael actually did a very neat demo of it yesterday. Kind of stole my thunder, but you get the benefit of hearing about the real thing because you came to the workshop. So we're going to talk a little bit more about the motivation for this feature and how it works in LabKey and the current limitations that it has, because it has a lot of benefits, but it's still very much a feature in development, so it's very much a work in progress. So getting to that nice thing that Raphael showed yesterday, it requires quite a lot of work, and I think most of that work was done by Raphael's group and developers. So really, Raphael talked a lot about the motivation for this, for standardizations and reproducibility of the analysis, and being able to track and access all the inputs. And really, what this feature is about is giving some more flexibility for users to plug in their own analysis or own R scripts or whatever. Right now it's set up for R, but you know, theoretically it should fit with any type of script, and use their own scripts to create their own analysis on big data sets that of any type of expression, gene expression, RNA-seq, any type of big data that comes out of that kind of studies. And really the motivation is for groups, most groups that do bioinformatics work, like Raphael's group, they want to have a lot of control on how they analyze the data. They want to be able to write their own scripts. They want to be able to write their own visualizations. And what we would like to do is give them the access to do that while using the built-in functionality in LabKey. So still being able to share the data, to publish the data, to standardize it, and give access to multiple users. So, and also I have to say that the demo we are showing today, so the feature is being developed by Kevin, who's standing right here with me, in collaboration with, and by funding of Raphael's group. But the demo we're going to show today is using data from another group that works with us, the Kate's lab at UW. And what we're going to do is we're just taking data, public data from one of their publications. They, when you publish a paper, you make the data accessible. So there's the gene expression data that you can just, sorry, that's an RNA-seq data that you can just download from Geo. So this is the data that we're going to use today. So what we did is we have the original expression matrix, the RNA-seq matrix that we downloaded from Geo in addition to the annotation set. And the annotation set, what it does is it maps the feature ID to the gene ID. So, and you can add, I'll show you later in the LabKey framework, you can add any type of metadata to the annotation set. And taking those two data set using an R script that we created in collaboration with the Kate's lab, we're going to do some filtering to the matrix. It's a very simple example, but what we're basically doing is taking this really big RNA-seq matrix and normalizing it into 6 probes. Sure. Yeah, 6 probes. 6 samples, yeah. And creating a normalized matrix that's easier to look at and do analysis on. Once we have the analyzed matrix, we have some analysis or some results that are shown on top of that data, a differential expression matrix or data set that's created on top of the normalized matrix, and some mean variance plot. And then you can use the built-in LabKey features to take that expression, differential expression data, and do whatever, analysis in R, or use the built-in visualization to see some more interesting stuff on top of the data. So before we go to future goals, let's switch to the server. So what you see here today is a module that was written for the purpose of a demo. This leads to one of the limitations of the current implementation of the feature. You have to integrate your R script and analysis into the code, into the module, so it's not as flexible as you want it to be at some point. So, one of the future goals for it is to have a user interface where someone could just plug in their script and it will automatically run with a pipeline. What you see today is a module that's been pre-created, pre-written by Kevin, right here, and just for the purpose of the demo. So I have 3 web parts. I have a couple of assays that I've predefined. So the expression matrix is the special type of assay in LabKey that is being used for this demonstration. And the final results is going to be stored in a general purpose assay that we call differential expression. We have the feature annotation web part. So the feature annotation set that's been uploaded simply maps the feature ID to gene symbol, but as you see, there are plenty of other type of data that you can link as part of the feature annotation set. And then finally, what I have here in the file browser is the file, the original expression matrix that was downloaded from Geo, from this publication. by the Kate lab. So the process is being triggered by the import data process. So when I choose to import data, I have many options here, as you see, and I think most of you are familiar with that LabKey feature. But using the import data process gives me the option of triggering the pipeline that will take the data from that text file, from the expression matrix file, and run all the scripts that we've integrated into the module and do the analysis for me. So as I click the import data button, it takes me to a page where I have to give some names and choose which essays I want to use as part of the process. So the expression matrix is my first essay, and I'm going to use the feature annotation set. I have the option to actually import the values of the matrix into LabKey. That naturally creates a huge data set in LabKey. I'm not going to do it now just for time constraints, and usually there isn't a requirement for storing the values of the original file in the database. Usually that's not the interesting part. People want to just do the analysis on top of these files. So what we do is we have pointers to the data in the text file. So creating matrix triggers the pipeline job that's running in the background. And if I take a peek at that, I have the log of everything that's going on as the job is running. This is something, the output that comes out in the log is also something the user can potentially influence by writing the appropriate code in the module. So if there are specific output that you'd like to see running as part of the log file, this is where you can add those. And let's see if it's complete. It's complete. So what I have now is, what happened as part of the pipeline is that I have 2 runs that's been created, and we can kind of take a peek at them using the run details view here, where I have my new 6 samples, normalized samples, that's part of the results of the analysis. I have a couple of inputs coming in where this is the original expression matrix, and these are the analysis parameters that were integrated in the module. So part of the R script that runs has these parameters built in. I have a couple of outputs that I can take a look at this point, which is the the filtered expression matrix and the counts file. So I have also the option of looking at all the files that were created as part of the process. They're all automatically stored in the file root for this folder. So double-clicking on this shows me everything that's been created. Part of the analysis is just we added code to create a variance plot that analyzes the data in addition to an MDS plot. But again, this is all what we would like to see people customizing and choosing what kind of plots they want to put on top of the data. And if we go and look at the differential expression matrix data set that was created as part of the run, this is sort of my final results as been set up by this demo. Just as a bonus, I have links with thumbnails to the images that were created as part of this process. Again, these are all part of the things that we want to see customized by the user when the feature's done. It's not there yet. So looking at this data set with all the differential expression results, I have the log concentration, log fold change, p-value, and so on. And this is just stored in a general purpose assay in LabKey. So everything that comes with a general purpose assay is now available for me to use. So I can create charts on top of it, and further extend the what everybody loves is the R analysis. So, create some kind of heat map on top of the data, which I don't think this is a very meaningful plot for this type of data, but just as an example of a functionality that you can do. And as any, again, this is not a special part of the module. This is part of the built-in LabKey general purpose assay functionality.
Is it knitter?
This is knitter, yes, which is also part of the built-in LabKey. Yeah, but this is just an example. So anything to add about the coder module that I forgot?
I think that's good.
Okay. So, yeah, so as I said, we're still working on it. We're very excited about this feature because we feel like it really pushes the limits of what you can do with LabKey. However, there's still a lot of work to be done here, and really getting to the point where you don't necessarily need to be an expert programmer to create that very nice looking module that Raphael showed yesterday. But being a user that wants to do analysis on top of data, being able to easily download public data from Geo and then plug in R scripts, or just use other people's R scripts, but being able to choose which type of analysis you want to do, how you want to, manipulate and play around with the data in a more interactive and easy way. Because right now you really have to integrate it into a module. And it's not working. Why is it not working? Okay, so yeah, so the Gotardo Lab funded this feature, and we keep working with them on that. Rich Green from the Kate's Lab helped us with this specific example, and Kevin, who did all the work that I just talked about. This is the paper we used for this specific example. If anyone wants this code for this demo, so just download the module and try it out yourselves. And if you want to play with the code, you can. It's available on GitHub and LabKey server. That's what we're here about. So, any questions?
That was going to be my question, is where can we find the code
Yeah,
for that?
so yeah, you can, there's, on GitHub you find all the resources, including the README file that sort of takes you through.
And it also has the sample data?
Yes, yeah, everything. And if something missing, just find one of it.
Yeah, as you said, it's a feature that is very, I think it's going to interest a lot of people, including me. But I get the feeling that you're not quite happy with the current architecture. So the code is available, but would you, do you want us really to keep along that line of architecture, or you think that there will be some changes very soon?
I think the groundwork is set. I don't see any reason why you can't start using it today. I think the process of developing the pipeline script itself is still, requires a little, patience. But it's totally usable, and Raphael, in his demo yesterday showed this parts and pieces of this. So yeah.
Okay, so thank you for all the presenters and everybody who stayed for the talks. Lunch is available. It's a little bit different format today, so it's going to be available for an extended period of time. So at your own leisure, when you want to grab something to eat, it's at the kitchen. We're going to have some of the hotel staff rearrange this room with tables. So right now, if you could either go downstairs, there are tables set up for work, or around the gallery area, some more tables set up. And all of LabKey staff is around here, and if you don't find someone, they will find you and come talk to you. So